All right, let's look at 2.2, polynomial operations. This all should be reviewed, but if it's not, we're going to go over it anyways. So for adding polynomials, you're just combining like terms. That's all it is. So we'll look at this first example. They're not in standard form, so we got to see which ones go with which ones. So we got 6x cubed and 2x cubed for 8x cubed. We do have an x squared. It's not the next term there like it should be. And we have one here. So we got, and that's 1x squared. So 1 and a negative 8x squared. 1 minus 8 is a negative 7x squared. Now we only have the 1x term, so it's plus 4x. And then we have negative 7 and plus 3, grand total of negative 4. Again, we're just adding like terms. They have to have the same exponent, and they have to have the same variable to that exponent. So why don't you guys give the next example a try. What we should have gotten for an answer is that, x squared minus 3x minus 4. Now going down to subtracting. Subtracting polynomials is the same thing as combining like terms, except we need to distribute the negative to the second polynomial first, because we're subtracting all those parts. So I'm just going to rewrite the first, actually I'm going to put them in standard form while I'm doing this, because that's ridiculous that they're not. X squared plus 4x minus 7. And then distribute the negative. So negative 2x cubed, positive 8x squared, and a negative 3. It just flips the signs of all the terms inside the parentheses there. So again, just combining like terms now. 6x cubed and negative 2x cubed is 4x cubed. X squared and 8x squared is a positive 9x squared. We got plus 4x, and that's it. And lastly, we got a negative 7 and a negative 3 for a negative 10. So this is our answer to that subtraction problem. So I'm going to give you guys a second, work on the next example. So hopefully we remember to distribute the negative. So we get a negative 2x, negative 4x squared, minus 7. So we combine our like terms. We should get negative 7x squared, negative 7x, and minus 4. So again, adding and subtracting polynomials with one change is just adding like terms. Now multiplying, a little bit more work, but something that we can handle. So we multiply each term in the first parentheses to each term in the second parentheses, and we combine like terms. So we use a box to organize the terms here. So this is just one method of doing this problem. We'll look at another method in a second. So we got 2m and a 5, and we got 3m squared minus 4m and a 2. So now we're just gonna multiply it out, kind of like a Punnett square that we may have seen in science. So 2m times 3m squared, well 2 times 3 is 6, and we add our exponents, so m to the first times m squared is m to the third. Now we go over to the next box. 2m to the first times negative 4m to the first. 2 times negative 4 is negative 8. M times m, we add the exponents, we get m squared. And lastly, 2m to the first times 2, well, there's no variable, so we're just going to have an m to the first, or just m. And 2 times 2, of course, is 4. Then we do the same thing with the 5. And obviously, it's not going to change our variables here, because 5 doesn't have one. So we're just multiplying the coefficient by 5. So 3 times 5, 15 still has m squared. Negative 4 times 5 is negative 20, still has the m. And 5 times 2, of course, is just 10. So we're not done yet, but we got to add up our like terms. Most of the time, I'm not saying all the time, most of the time, our like terms will be diagonal from each other. So our solution is 6m cubed. We only have one m cubed. 15m squared and 8m squared is a positive 7m squared. Negative 20m and 4m is a negative 16m. And then we just have the 110 chilling by itself at the end. So when we multiply that out, we get those four things. Now, doing the same method, but looking at it slightly different, we can just distribute. Double distribute, because we have 2 terms times 3 terms, so we got to distribute the 2m and then the 5. And that's exactly what we just did in the one above, but we didn't write it like that. So 2m times 3m squared is 6m cubed. 2m times negative 4m is negative 8m squared. And 2m times 2 is a positive 4m. Now we do the same thing with 5 times all three of those things. And I'm going to kind of move over a spot so we can have the like terms add up together. So 5 times 3m squared, well, it's still an m squared, because 5 doesn't have a variable, and 5 times 3 is 15. 5 times negative 4m, we still have an m. 5 times negative 4 is a negative 20. And then lastly, we got 5 times 2, of course, that's just 10. And now, when you add down, we get the same answer that we got in the other one, or the other method. And if there's a third method or a fourth method you can think of, go for it. That's fantastic. All right. I want to give you guys a second to try this multiplication problem. So either method, just multiply it out. So if we were to do, well, either method, you're going to get the same 6 terms to begin with. Oops, that's not 13. And we should have gotten 10m cubed minus 17m squared plus 33m minus 6. All right, we got some more multiplying examples, so I want to show them off. So first off, what I have to impress upon us is that 2x plus 3 squared is not 4x squared plus 9. That is not the case. Two x plus 3 squared is 2x plus 3 times 2x plus 3. Because that's what squared means, times itself. So then we got to do our double distribution, or our box, and then we multiply it with the x plus 7. So we have to do a couple different steps here. So I'm going to give you guys, actually no, we'll do this one together. So we have 2x plus 3 times 2x plus 3. And we'll deal with the x plus 7 in a second. We got to pick 2 of them to multiply together first. I'm just going to do the 2x plus 3's. And then we'll multiply in the x plus 7. So I guess we can do a box here. So 2x times 2x is 4x squared. 2x times 3 is 6x. And 3 times 3 is 9. So when we simplify it, we get 4x squared. We got like terms here, so plus 12x plus 9. Now we got to multiply it by x plus 7. So we're just going to distribute those terms. We get 4x cubed plus 12x squared plus 9x when we multiply by the x. When we multiply by 7, we get 28x squared plus 84x plus 63. And of course, we add up our like terms, and we're looking at 4x cubed plus 40x squared plus 93x plus 63. All right, I want to give us a second to do this one. So remember what that means. What is it? X minus 4. So it's x minus 4 times x minus 4 times x minus 4. I'll give you a second to work on that, see what you can come up with. And that's when trying to do it in your head is not a good idea, even for me. So I'm going to multiply these out. And then negative 4 times all that. When we finish that one off, this is our final polynomial. So just make sure you multiply everything in one set of parentheses with everything in the other set of parentheses. All right, letter C. If p of x equals x squared, r of x equals 3x squared minus 4, find p of x minus r of x and p of x times r of x. So it's the same thing that we were just doing. The difference here is, well, they just wrote it a different way. So p of x minus r of x, and I put it in parentheses because we want to subtract that whole thing. So x squared, we distribute the negative, negative 3x squared, and a positive 4. So when we simplify that, we get negative 2x squared plus 4. So not a super tough problem or example. Now p of x times r of x, so that would be x squared times 3x squared minus 4. And really it's just one term times two terms, so we just distribute. 3x to the fourth minus 4x squared. And that's as simple as we have to go. Now there's a question just like this on our LTQ. So let's make sure we know how to do this. So we have this rectangular piece of cardboard that's 12 inches by 15 inches long. And we have that. We got the 12 here, we got the 15 here. Squares, x inches on each side are cut out of the corners, and the sides are bent upwards because we're going to make a box, make a 3D box. So our new dimensions are going to be taking out these x's. So this side, where it was 12, well, we took off an x, we took off another x. So this little part is 12 minus 2x, as is this, since it's a or a rectangle. 2 x's, so that's why, well, we have 2 x's. Then likewise, the whole length is 15 inches. But if we take off an x on the left and an x on the right, we get 15 minus 2x, and 15 minus 2x. So our length is 15 minus 2x inches. The width is 12 minus 2x. And then the height, well, when we fold those sides up, it's that height, which is just x. So that's going to be the 3 dimensions there. And it's always going to be the same. It's going to be the length minus 2 times x, the width minus 2 times x, and the height of the box is going to be x. So now to find the volume, we got to do length times width times height. So 15 minus 2x times 12 minus 2x times x. It doesn't matter what order you multiply them in. I'm just going to do these first two. We'll do double distribution. So 15 times 12 is 180. 15 times negative 2x is negative 30x. Negative 2x now times 12 is a negative 24x. And negative 2x times a negative 2x is a positive 4x squared. Combine our like terms, and I'm actually going to flip this around and put it in standard form. So we get 4x squared minus 54x plus 180. But then we have to multiply it by x because we still have that other dimension there. And all that does is add an x to each term. So the volume of the box would be 4x cubed minus 54x plus 180x, inches cubed. And that's all we're doing there. So now I want you to try this last problem. Again, it's just like one that we're going to see on our LTQ, so make sure that we know how to do this. All right, so I hope for our length, we got 14 minus 2x. Our width, 10 minus 2x. And the height of the box is x. So we got to multiply those out. So if we multiply all that out, we get 4x squared negative 48x plus 140. And then times the x, we get 4x cubed minus 48x squared plus 140x inches cubed. And that's the volume of our box. And again, that's what we need to be able to do.